Good morning, Sunday, February the 9th, 2023, and I've come to the last problem of section 4. We have derived two functional equations, so I've written them up here, and I feel very confident about this one. But I would like one more reality check on the second one, and we will get that down in question B. If I can arrive at that, then this must be right as well. And this means that we must use these two equations to eliminate this term. And if we multiply the last equation with the imaginary unit, then this becomes 1. And then we have to multiply this one with this and this one with this anyway. So I'll just multiply this one with the imaginary unit. There we go. So if we multiply by minus I, it becomes what we had. And then we multiply this equation with this part. And then write the other guy, pi minus s halves. Oh, now we can use the reflection formula of the gamma function. And then times this. And then we must add, and then this is it, times this. There was an imaginary unit as well. Pi to 1 plus s halves. That is 1 minus this gives this, here's the same possibility. And then the product of these two. Maybe we should write that as minus 1 plus s halves. And then we just add these two, so this guy cancels, so it gives twice. A1 minus S. In terms of these two guys. All right, so it's time for reduction. And this is, of course, the tricky part on the tablet. I'll just do it. Pi to minus first. And then this, we can use the formula, but it's with S halves, so now this has poles on all integers, so it's something divided by sine pi s, and then the poles here are pi, so, and here the poles have residue 1, so I think it's pi up here. I'll just check that formula. I was right. All right, so this gives pi divided by sine pi s. They cancel as well. And then times the sum of the zeta functions. And this is minus 1/2 plus 1/2 plus S halves plus S halves. And then the gamma, that the sum of those two is unity as well, so we can use the same formula. Or 1 plus S halves, whatever you want. Now that's weird. That should change sign, shouldn't it? If we check, oh, that's the reflection. That's the reflection formula of sine. Yeah. And then 2 and pi plus S halves plus F halves minus, my God, that's complicated, minus 1/2 minus 3/2 plus S. We'll just work on this down here. As I see it, they are incompatible. can't reduce that at all, so just write it. And this was with the 2 subtracted. Maybe I should check the formula from problem 5, do that again. Well, I don't know how to do it, so I'll take a break and then get an idea how to go on. So what I would do if I had to work on it now was redo the derivation of this formula as I already did with this one, and then hopefully some reductions would become possible. Otherwise there must be a reduction that I've missed here. Now it's the afternoon. Oh, it's already 4 o'clock. I went to tennis, had lunch, and then it was almost 2 o'clock. Then I oh, I don't have the paper here. Well, then I checked this second formula and I got the same, but I discovered a little mistake though, that the exponent of pi is minus the argument of gamma, so we need to put a minus in there. And that will change gamma 1 plus s, then it's minus here. And then we get pi to minus 1/2, that's minus 1. And then plus s halves minus s halves. I don't even know, that's the plus. Plus s halves minus s halves. So that should, but it already cancels here. This is the sum of the set of functions, and it's on the second one the problem was. Oh yeah, pi to s, that we do without that. But we still get pi to minus first. So that's the correction. That took a while. And then I realized that the formula, well, and then I've already started on problem part B of the problem, and formula 4,4, I wrote that here. It's very close to what we have here. So maybe we should not make this reduction, but rather wait a while and divide on both sides by this, but then making this. So to use this on the right hand side, we must substitute s with 1 minus s, and then 1 minus s, that becomes 2 minus s, so that's what we have here. So that means we can write this part. Yeah, let's just do that. 2 to pi minus 3/2 plus s square root pi 2 to, and we should substitute s with 1 minus s, so 1 minus s minus 1, that gives minus s. Gamma of 1 minus s. And then let's see what, we can reduce it. Let's do that first. 2 to 1 minus s pi to minus 1 minus s gamma of 1 minus s L of a.1 minus s. Now we can finally isolate L of a.1 minus s equals, and then I'll go back and use the original formulas, the original products here up here. But you know what, I can't do that while recording because I have to be able to see this result. Oh, I can do that, and then I have to copy it up to the next page. Yeah, let's do that. And then this guy, so that was pi to minus first. They both gave pi to minus first, so we'll put it in the denominator. And then ups. Gamma of 1 minus s halves, gamma of s halves. That doesn't really give us anything. So maybe we should do this anyway. I can't see how we can continue from there. However, well, I think I have an idea. So let's just write it. And let's leave that. Now, have I done something wrong up here? When I use this one with these two, then it becomes sine of, yeah, I have it of 1 plus s halves. and from the first it's s halves, it should be s halves here. That was another mistake. So 1 minus s halves, so that's s halves here. There we go. That makes more sense. This of course gives a cosine of pi s, but my idea was to write this as another product of this kind, because we can, what can we do? We can always add a factor 2 pi or minus or pi and then change sign. So we actually get new products. And one of them might cancel with this. Yeah, I'm not getting anywhere. And I have no idea how we can reduce it to this form. I got the gamma s here, so if we, what is it called, extend the fraction with gamma s, then down here we get 1 divided by pi s. Oh, now that's actually interesting. That's actually interesting. And then we can apply the, I hope, let's try to do that. So I'll make a pause, no, then it'll stop. So yeah, I'll make a pause and then copy this to the next page and then try doing what I just said. I have copied the formula to the next page, and then we extend with gamma s to 1 minus s, and then we get a pi here, so it's pi to minus s. And then gamma s times gamma 1 minus s equals pi divided by sine pi times s, pi s. Oh, and this should be with the minus. Check. Ah, and now this becomes cosine. So 2 to s minus 1 pi to s minus 1. This gives minus s plus 1. Gamma s. And then sine pi s divided by sine pi s halves plus I sine pi s divided by sine pi 1 plus s, and that was equal to cosine pi s. And then we use the multiplication formula, doubling formula for sine. and that cancel. And here it's cosine that cancels. It's S halves. So we take a factor 2 out. And then cosine plus I sine and that was, as far as I remember, I'll just check it, L of A point L of A 1 minus S point comma 1 minus S plus, and then the difference that's cosine minus sine and now we must compare with the result I was supposed to get. Gamma S, so we set that guy here outside parenthesis. Oh, there's an I missing, isn't there? No, it's all taken care of. All right, and I don't have what I need to compare with on the same page. It seems that 2 pi minus S, I get pi to S minus 1, and 2 to S, so there's something wrong with these powers. And next, however, this seems right. So from here it's correct, it's just the constant I got wrong. I don't want to spend time while recording doing that, so I'll stop for now, and then we'll take a look at it, maybe later today, maybe tomorrow. It turned out I made a number of mistakes. The first one was that I copied the formula 4.4, exchanging 1 minus S, and that means we should have, when substituting S with 1 minus S, we get 2 to S down here, do we not? 1 minus S, that gives S. And the pi came from up here. So this leaves us with pi to minus S. There's a total. And going to the next page, pi to minus s, but we should have 2 as well, this time to s. Oops, it should be minus s. To get s halved, we substitute s with 1 minus s. Yes, that's what it says in here as well. So 1 minus s, and then it's minus 1 plus s. Should give 2 to s, and then pi to plus s as well. There we go. Then this, of course, is the zeta function. And what more did I do wrong? We have already taken this into account. So we do get 2 pi to plus s. But then we get a factor 2 even more. And then just pi to s. Now we are pretty close, except for that it should have been minus s. I get plus s, and then I'm a factor 2 out. So I did improve a bit. What I'll do is the usual thing. I'll stop and then do it on a sheet of paper where I can have all the formulas visible simultaneously. That makes it much safer. Hello again, it's now February 21st, 10 o'clock, 2023. I think I have the solution to the last problem here. I've made some mistakes. The first one was we need to take L of 1 minus S, and that was if it was S in the definition. I just wrote the definition without substituting 1 minus S here. And that means it must be S minus 1. And next, we just substitute S with K. So it's that's a little weird. Oh, this comes from the formula from problem C, so we don't have to substitute anything there. And then when we let S be K, then it's e to pi I. Shouldn't that be minus, by the way? It's moved to the other side, so it should be a minus as well. So it's still minus 1 to K. And then that minus 1 can be put in here. I'm missing I to the kth. That's weird. Well, I don't know where that comes from. Probably forgot it somewhere. Not here. Well, let's get on with the next part. I realized this minus 1 to the mth. And when we use it down here, where do we set it equal to that? I don't. Well, then we should have minus 1 to the mth. Oh, here it is. And that becomes K minus 1, I think. So we put it on the other side. And then this minus makes it minus to K, and then we put it in here. So see, twice I get alternating sign. I couldn't believe it because I haven't really found a significant mistake in any equation in the book up until now. So I thought I'd better check it. And I did. So we work with 20 digits to be able to compute this sum. And I use the first 50,000 and 100,000 terms. I set A equal to 3 times the imaginary unit and K equal to 3, 4, 5, and 6. And we compute the sum. of the inverse powers, translated A, and we get an imaginary number up to like 7 significant digits. And then we insert, compute the right hand side after the formula in the book. Now it's becoming faint-hearted and used the formula in the book. And as you can see, the right-hand side gives the opposite result. When n equals 4, it gives the same, this time being real. When n equals 5, it's the opposite, imaginary. I hope there is an I there. Yes, there was. And when n equals 6, it's the same, a negative real number. Now, that finishes section 4, and I even found an error in one of the formulas. Surprised.